Hello, hello. I see that no one has joined yet, but anyways, I will begin. Uh, uh, People can join later or watch it offline. I mean, not offline, but watch it when it is not live, the recorded version of the stream. So yesterday covered the core web vitals article of this web.dev. Today we are going to continue with largest contentful paint. Yesterday I did not take any notes. I noticed it later. It's completely blank. So I'll try to take it today while learning, or else I'll do it afterwards and update the document. I'll share this document later. But again, creating your own notes is always more helpful to you. But yeah, let's continue. So when we were till we reached till here, at least I think, remember over here, but again we can revise it. So basically, if just want to revise what is core web vitals, then there are like web vitals which are important to help us measure performance and help us uh, give a better user experience to the website users. And among those web vitals, there are core web vitals, the three main web vitals, on improving which we can create actual impact. Okay, so only if we focus on these three, they will actually make the user experience way better. So those three are largest contentful paint. Then comes the first input delay and the cumulative layout shift. So today we'll be looking into the cumulative layouts. No, no, sorry. Largest contentful paint first. And then we'll see according to time, like in an hour or maybe 1.5 hours. We'll see how much you can cover. So, largest contentful paint is an important user-centric metric for measuring perceived load speed. So I already told it what is perceived. So basically, you- if we just improve the speed, I mean, if we improve the matrices, but if the user is not able to see any difference between before and after, then that just doesn't matter. So that's why it's known as perceived. The perceived load speed should increase. So how quickly a page load a page can load and render all of its visual elements to the screen. Okay, so this is the definition of what perceived load speed means. How quickly a page can load and render all of its visual elements on the screen. Cool. So it measures that because it marks the important point in the page load time when the page's main contents is likely to be loaded. Okay, fast LCP helps reassure that the user that the page is useful. Yesterday we saw what do you mean by useful. Yeah, it's again given somewhere over here. uh, yeah, has enough content rendered that the user can engage with it. Okay, so yep. Historical is a challenge for how quickly yeah, we read about this like yesterday itself. So earlier people used to use either load or DOM content loaded event. It used to wait for these event to know whether the UI is rendered or not, but that was not mapping to actually what user was seeing on the screen. Then they tried this web vital of first contentful page, but then the issue was that they capture only the very beginning of the loading experience, like just like if there is a splash screen in your app or there's a loading indicator, so that they capture that. So by capturing that, you don't actually understand whether your website has loaded a good chunk of your UI, right? So that's why they use the LCP as the core metric. In past also we have tried first meaningful paint and speed in text, so we looked into it yesterday, though yesterday in the last learning session, that FMP is almost similar to FCP. Slight differences are there, and speed index both available in Lighthouse. They help capture the loading experience of initial paint, but these were complex matrices, so they were hard to explain and often interpreted in a wrong manner. So that's why the based on the discussion with W3C Web Performance Working Group and research done at Google, they found the LCP as the standard metric. So the LCP metric reports render time of the largest image or text block. Okay, so we learned about that yesterday. So these are the elements which constitute the LCP. So it could be the largest image element or an image inside an SVG. Okay, so if within an SVG, or a video element. Okay, an element with a background image loaded using URL, not CSS gradient, but URL. Um, and block level elements. So this comes with the textual node, largest textual node. So block level element, any block level element, and within that, if there are any inline, then that's fine. But it should be a largest block level element. So yep, that's it. That's it. Visible within the viewport. So it should be visible within the viewport. So if we currently look at this, so let's say this is not so big, but this is big. So this will be our LCP. But if we scroll a bit, then this becomes the LCP, right? But since it is not available in the viewport as of now, so if I just scroll a little, this is not completely available in my viewport. So I may consider this, or maybe this actually. This is a bigger one. Sorry, this is an image, right? It's a big image. So this would be the LCP for this current view of the page. Okay. So and here relative to when the page first started loading, meaning when the page was navigated. As soon as you click, the navigation happens, right? Or if you're in a website, any other website, and you click and it navigates to the new website, so that is the start time. So the navigation is the start time, and from there, that time till the time the largest contentful page block or image appears, that is known as, that is how you measure your LCP. So we know less than 2.5 seconds is good. Anywhere between 2.5 to 4 is okay, needs improvement, and above 4 is just poor. And that's what we learned. And to ensure you're hitting this target for most of your users, a good threshold of measure is 75% of page loads segmented across mobile and desktop devices. So you just take a percentage, 75% of all the users that you have in different devices, and if you are able to increase this to, I mean, if you are able to keep the LCP between 0 to 2.5 for 75% of these devices, then you are good to go. Then how, if you want to see how and the research occurred and what methodology was used, then you can go to this defining core web vitals with text threshold. Yeah, what elements are considered, we already know. Now here, how the element size is defined. Size of the element reported for largest contentful page is typically the size of that's visible to the user within the viewport. So yeah, we already discussed that. If the element extends outside of the viewport, or if the element is clicked or has non-visible overflow, those portions do not count towards the element size. We learned about this yesterday. For images that have been resized from their intrinsic size. Okay, so let's understand this. Intrinsic size of an element is the size it would be based on its content if no external factors were applied. For example, inline elements are sized intrinsically. Width and height and vertical margin and padding have no impact, though horizontal margin and padding do. Yep. So if you are aware that in inline elements you cannot give width and height. Okay. If you want to do that, then you have to at least make it a display of your inline block. Then you may be able to give it width and height, but otherwise you cannot give width and height. So that's what they're trying to say, that an element, the intrinsic size of an element is anything that before applying any external factors, like if you give any height or width or give padding, margin, anything, before that, whatever the size of your images, that's what it is. So so that's what it is. If the image has been resized from their intrinsic size, the size that gets reported is either the visible or the intrinsic, whichever is smaller. Okay, so if you are trying to increase the size of your original image, then it won't work. It has to be either the visible or intrinsic, whichever is the smaller. For example, images that are shrunk down to much smaller than their intrinsic size will only report the size they are displayed as, whereas images that are stretched or expanded to a larger size will only report to their intrinsic sizes. So let's say if you do I think if you do a content display, no, not display content, there's an image, right? So there's a property object fit. I think if you do object fit stretch, then I don't think it will consider the stretched image. It will consider the intrinsic image size. This is what I'm thinking. Even I'm learning. I'm not sure about this. We'll explore that. For text elements, only the size of their text nodes is considered. So I see a couple of people have joined. Okay, so if you guys have any questions, do mention. For text elements, only the size of their text node is considered. The smallest rectangle that encompasses the text nodes. Yeah, that's not nothing much to explain over there. For all elements, any margin, padding, or border applied by CSS is not considered. Okay, this is important. So for all elements, the margin, padding, and border, it's not considered. Just the actual content length or size. Determining which text nodes belong to which elements can sometimes be tricky, especially for elements whose children includes the inline elements and plain text nodes, but also block level elements. The key point here is that every text node belongs to only to its closest block level and sister element. In the specs term, each text node belongs to the element that generates its containing block. Okay, I might need to read it again. Determining which text nodes belongs to which elements can be tricky, especially for elements whose children includes inline elements and plain text node, but also block elements. The key is that every text node belongs to and only to its closest block level ancestor. So yeah, there could be confusion if like a block level element has a couple of inline elements and also block level elements within it. So they have defined it like every text node belongs to and only to its closest block level ancestor element. Okay. Cool. So this is simple. In spec terms, each text nodes belongs to the element it generates that generates its containing block. Let's see what is containing block. Content. Depending by we all know this. Example, paragraph is statically positioned, so its containing block is section because it's the nearest ancestor to the block. Okay. Paragraphs containing block is body because section is not a block container. Okay, cool, got it. So basically, if your text node is like this, right, then P, whose is which element is its what is it, containing block? It is section because section is a closest block level element. Okay, but if you explicitly make it inline, then it will go to the above parent. So before section, this is body, so that will become its block level element. So that's what they're trying to say. Now let's coming back to our own topic. Each text node belongs to the element that generates its containing block. Cool. And here also they have mentioned every text node belongs to and only to its closest block level ancestor element. So it's clear, like if you have something like this, okay, then whoever is its closest ancestor block level element, whether let's say in between if there was one more div tag and that had display of inline, then that would not be its parent. It will go above to the section and the section will become its block level element parent. Cool. When is largest contentful paint reported? Web pages often load pages in stages. As a result, it's possible that the largest element on the page might change. To handle this the browser performance entry dispatches performance entry of the type largest contentful paint, identifying the largest contentful element as soon as the browser has painted the first frame, but then after rendering subsequent frames it will dispatch another performance entry anytime the largest element changes. Okay, for example, on a page with text and a hero image, the browser may initially just render the text, at which point the browser would dispatch largest contentful paint entry whose element property would likely reference a P or H1. Okay. Later, once the hero image finishes loading, a second largest contentful paint entry would be dispatched, and its element property would be referenced to image. Okay. Cool. So I hope that was clear. Like it's if there are multiple like while loading the first frame and after second frame we see that okay now the one in the second frame is actually the bigger one. Then it will the largest contentful entry will be dispatched again. Okay, using this performance entry. So let's just see if what is this performance entry. Okay, a performance entry object encapsulates a single performance metric that is part of the performance statement. Okay, so cool. For example, on the page, okay, it's important to note that the element can only be considered the largest contentful element once it has rendered and is visible to the user. Images that have not yet loaded are not considered rendered. Okay, understood. So let's say if you have given height and width to an image tag, but the image is not loaded, then it might not be considered, even though it has a good height and width, meaning it's covering good area. It will still not be considered unless it is loaded. Okay. Neither a text node using web fonts during the font block period. Okay, so let's see what's font block. So if we are using external, what I understand is like if we are using external fonts, so they might have some sort of different area, right? Font area. So by default, when the content is being loaded, it will default to your browser font, and when the font is loaded, okay, then at that time it will update that font. So I think that's what they're doing. Font block. If the font face is not loaded, any element attempting to use it must render an invisible fallback font face. If the font face successfully loads during this period, it is used normally. Any element attempting to use it must render an invisible font face. What do you mean by invisible fallback font face? So if I'm understanding it correct, meaning like until the font face is not loaded, we don't show anything. We just like we block that area, like we have the height and width of that area, but we don't show any text is what I understand. And if it is successfully loaded, then we see the normally. So what I explained earlier was font swap period. If the font face is not loaded, any element attempting to use it must render a fallback font face. And if font face successfully loads during that period, it is normal. If it is not loaded, user agent treats it as failed load, causing the normal font back. So that's it. So if like for any reason like your URL was long or the CDN is down from where you are getting the font face, then it will fall back to the user agents. User agent is usually browser, so it will fall back to the browser's default one. I think that's what it means. Yeah, font swap period is like fallback. So if you see, usually when you are using CSS, you just don't give one font, you give three. Usually I've seen that's the practice. So first one is the one you actually want to use, then two are the fallbacks. That's what I've seen. So this is what that font swap period, and this is what I understand is that okay, got it. Okay, now I understand it better. So font block period, if the font face is not loaded, then any element attempting to use it must render the invisible fallback font, meaning it will occupy the space according to the fallback one, but it will not show it. I hope you understand it. Cool. For example, on a page, where were we? Yeah, block period. So neither are the text. What does neither mean? Images that have not yet loaded are not considered rendered. Neither are the text nodes using web fonts during the front. Okay, those are also not considered as the LCP until till the time they are in font block period. In such cases, a smaller element may be reported as the largest contentful pane, but as soon as the larger element finishes rendering, it will be reported via another performance entry. Okay, so till the largest element in your page, what I understand is still the largest largest element in your web page is not appearing, like not completely loading. So it may capture false largest contentful page, but eventually they keep dispatching this performance entry. Okay, so it will then correctly map it. So yeah, that's what I understand. In addition to late loading images, font or page may or add new elements to the DOM as new content becomes available. If any of these new elements is larger than the previous content, the new performance. Okay, again, let's say your JavaScript, because of your JavaScript code, or new DOM has been added, right? Then that will also be causing the dispatching the performance entry, and then that will become the largest content element. If an element that is currently largest contentful element is removed from your viewport or DOM, it will remain the contentful unless a larger element. Okay, this is something new. So if an element that is currently largest contentful element, it is removed from a viewport, okay, or even removed from the DOM, it will remain still the largest unless you find a larger element which that is rendered. Fine. uh, okay, so earlier it was not like this point was not valid, but due to the popular UI patterns like image carousels that often remove DOM elements, the matrix was updated to more accurately reflect the user experience. Okay, the browser will stop reporting new entries as soon as the user interacts with the page. Okay, as the user interaction often changes what's visible to the user, especially well, it's very true. Okay, okay. So let's say you have like your LCP is like the fourth element that is supposed to happen, but after the third element itself, the user starts scrolling or doing something. Then the third element itself, the third largest element will be the LCP, and the fourth one will not be considered as LCP. Okay, so that's why measuring it in the actual field is important, because we have to see how users are going to use it. Because in lab environment, in your own lab desktop, you will be waiting. Okay, I know my largest contentful node has not yet loaded, but in actual field, what will happen is that user might think, okay, it's page is loaded enough, so I'll just scroll. Okay, so at the time that will be different. So you will have to optimize that particular element and not the actual LCP. Yeah. For analysis purposes, you should try only report the most recently dispatched to your. Yep, yeah, this is what correct. Okay, so let's say if the user has clicked on your website, then while it's loading, he goes to some other website and comes back. So only when he comes back will the browser start reporting the LCP. Okay, so that's another caution. Okay, cool. Mm, load time versus render time. For security reasons, the render timestamp of images is not exposed for cross origin images that lack timing allow origin header. Instead, only their load time is exposed. Since that is already exposed via many other web APIs. Okay. Load time versus render. For security reasons, render timestamp um, of images is not exposed. Timing allow origin response header specify origins that are allowed to see values of attributes retrieved via features of resource timing API, which was otherwise reported as 0 due to cross origin restrictions. Reliable retrieving and analyzing detailed network timing data regarding the loading of an an application can use timing matrices to determine, for example, the length of time it takes to load a specific resource, such as XML, HTTP, image, or script. Okay, okay, okay. So, kind of sort of understanding it. Timing allows specifies origins that are allowed to see values of attributes retrieved via features of resource timing API, which would otherwise be reported as zero due to cross-region restriction. Okay, I understood. I think I understood. So resource timing API is the API which helps us see the render time, calculate the render time. Now, if you are getting an image from some resource, let's say you googled some resource, okay, or you somewhere, basically somewhere it is hosted, okay, someone hosted, and you like that image and you are trying to load it in your app, okay. So that image so that image server, wherever it is hosted, they should have your website in their timing allow origin, okay, or they should have it at star also is fine, star meaning any origin is fine, or otherwise it should have your website, the website is trying to load that image in their timing allow origin. Then only they'll be you will be able measure, sorry, you will be able to measure the render time. Otherwise it will be reported as 0. Okay, cool. Okay, for security reason, render timestamps of images is not exposed, fine. Instead only their load time is exposed, since it is already exposed. Okay, the usage example below shows how to handle elements whose render time is not available, but when possible it's always recommended to set timing on a render. So matrix, yeah. So if you are in the control of your own server, then obviously give your origin your front end origin in your timing allow origin header, so that you are able to calculate that correctly. How are element layout and size changes handled? To keep the performance overhead of calculating and dispatching new performance entries low, changes to element size or position do not generate new LCP candidates. Only elements initial size, position, and viewport is considered. Okay. So like if your element changes its size, okay, then it will not dispatch any new performance entry. It will no new LCP will be considered. Only the initial size and position will be considered. So this means images that are initially rendered off screen and then transition on screen may not be reported. It also means that elements initially rendered in the viewport that then get pushed down out of view will still report their initial in viewport size. Yeah, I understood. So basically, let's say you are loading your web page, but the initial view of your web page does not have the image. Only when you scroll down it has the image. So obviously that image will not be considered as LCP candidate. Also, let's say you are loading, you have a block. Okay, you have a block, but that gets pushed down, further loading the further painting of the browser. That gets pushed down. So then that will be considered. That element would be considered in the LCP. Okay. Here are some examples of when the LCP occurs on a few popular websites. Okay, so this is when LCP is considered. Okay, so if you see, it keeps on updating, I guess. So here till here it was this, then it became this, I guess. Still this, and now it became this. So the green marker is the LCP candidates, if you notice. So this is the practically they are showing how the LCP changes over time while rendering the UI. So let's say here also this. Okay, so what happened here? I think scroll or something happened. I'm not sure. Okay. So this got pushed down. I think that's what I'm thinking. This got pushed down. So then this came. or you clicked on this, because see this is here, you click on this, then I think it opens up, and then this is considered the LCP. So while loading itself, I think if you click when I that's what they said, if you're while loading, if user interacts, then they stop calculating the LCP. Okay, let me understand what's happening. So this is your latest. Okay, this is your LCP. Fine. The images are not yet loaded. Now here the images are loaded. This is LCP. But I think they have clicked here. That's why this is opening right like this. Otherwise it will not open. So do you mean to say if you click also and go to the next page, still they continue calculating the LCP? But here they said they don't. The browser will stop reporting new entries as soon as the user interacts with the page via tab, scroll, or key press. This is quite confusing. mm, hmm. Both of the above templates, the largest contentful changes are as content loaded. In the first example, a new content is added to the DOM, and that changes the what element is largest. In second example, layout changes and content that was previously the largest is removed from the viewport. Okay, okay. While it's often the case that late loading content is larger than the content already on the page, that not necessarily true all the time. So next 12 examples for the largest content will be occurring before the page fully loads. Okay, this is the Instagram app, I think the old one. So this is your first LCP. This is your FCP. So that's why FCP is not considered, right? Because it's just this. I mean, first contentful paint. So this does not give the users the satisfaction that it's usable. The app is usable. So that's why they moved to LCP. So now this will become the LCP. Then this becomes the LCP. Now this is the final LCP, because here if you see, other elements that are being loaded are not larger. So yeah, this becomes your LCP. So this is quick, I think. Again, this here for FCP, and this is FCP. It does not change because there is no larger image or text node. Cool. The first example, the Instagram logo is loaded relatively early, and it remains the largest even the other content is in progressively shown. In Google search result pages example, the largest element is the paragraph of the text node that is displayed before any of the images or logo finish loading. Since all the individual images are smaller than this paragraph, it remains the largest though the process. Okay, throughout the process. Cool. So I think we are over half the time. Let me just take a 2 minutes break and we'll continue. Let's continue. So, yep, till here you have covered the first name of the Instagram timeline. You may notice that the camera logo does not have green box around it. That's because it's an SVG element, and SVG elements are not currently considered an LCP candidates. Okay, cool, good note. So SVGs are not considered, but if there is an image within the SVG, that will be considered. Okay, so I'll just clarify that. Image elements inside an SVG are still considered, but SVG itself is not considered. Cool. How to measure the LCP? LCP can be measured in the lab, um, or in the field, and it's available in the following tools. So both tools are there. So field tools, Chrome user experience report. So let's see the CRUX, something like that. Mm, here they are saying these three only. Okay, there's this dashboard. Okay, so some dashboard is there, so you can either use that, but usually you don't use that. Page speed, that's the best option. That's what I demoed in the first session also. Page speed insights. Search console. Again, this one I want to see what is the search console thing. Oh, this is search console over here. Okay. Okay, not sure what is happening, but yeah, you can use this if you figure out how to use. But at least we know one of them: page speed insights, and yeah, the library that we all know. And usually, this is how you should use. So basically, in your code, you have to add this npm library, and then that option was there, right? Get LCP and get FID. In that, pass your analytics callback. Okay, so it will be directly deported to your dashboard, analytics dashboard. So those are the field tools, like actual production code. And then lab tools, you can use the dev tools, lighthouse, or web page test. Okay, so dev tools, I think your performance is what they will tell you. Okay, there are lots of dev tools, but yeah, I think you can use the performance tab. Lighthouse, I already showed you, that's a separate tab in your dev tools. And web page test, this is something that I didn't know. Okay, so okay, this here also you can, this also you can use. Okay, great. Web page test for lab. Okay, measure LCP in JavaScript. To measure LCP in JavaScript, you can use the, yeah, so this is like plain JavaScript. This is the API that they provide. Okay, like npm library that they provide, where you can directly call the functions and do it. Here, if you want to implement it on your own, measure on your own, okay, then you can use the web API is available. So you can use this API. Let me see if this is available in all of the browsers or just the. I don't think here they will be able to tell me. Which I can check. I can check over here. Maybe just Contentful Paint. Here it is. Yep, it's not there in Firefox or Internet. Anyway, nobody cares about Internet Explorer, but it's not there in Firefox. So it will work only for Chrome, Edge, and Opera, but not even for Safari. I understand why for Chrome and Edge, because both of them use Chromium. Great. Firefox, nope. Internet Explorer, though. Anyways, no. Just a recommendation: if you are anyways developing any web application, target for Chrome, Firefox, Edge, and Safari. Those are the most used browsers. Um, yeah. So to measure LCP in JavaScript, you can use this API. But if you use this API, then you will have to write a polyfill for Firefox and Safari browsers. So if you know your users are only going to use it in Chrome, then go ahead, Chrome or Edge. The following example shows how to create a performance observer that listens for large LCP entries and logs them to console. So new performance observer entry list. So again, this is a performance observer class. Interface is used to observe performance measurements events and be notified of any new performance entries. So okay, so performance entries already we saw, right? Those are the object that encapsulates any single performance metrics. Okay, so performance observer basically is an interface that observes, okay, if such any of this such event is fired. Okay, uh, so the new performance observer, so I think entry list will be the list of, will contain the list of all the performance entries. In that we will just check, we'll just observe the type of largest contentful page. Okay, cool. For example, each entry represents the current LCP candidate. Yeah, so this code will represent basically all the candidates. So during the entire loading phase, rendering phase, all the candidates that are LCP, that will be logged. Okay. In general, the start time of value of the last entry emitted is the LCP, but like it's always that the last LCP that you saw and its start time. Okay, that's the actual LCP. Okay. However, not always the case. Not all LCP entries are valid for measuring LCP. The following section lists the differences between the what API reports and how metrics is calculated. So differences between the metric and the API. The API will dispatch LCP entries for pages loaded in background tab, but those pages should be ignored when calculating LCP. Okay, okay. So if your page is in the background, like someone is on off the tab, so those will be loaded. So, but those should be ignored. The API will continue to dispatch LCP entries after a page has been backgrounded, but those entries should be ignored while calculating LCP. Even elements may only be considered if the page was in foreground the entire time. Okay, again, I think similar points. API does not report LCP entries when the page is restored from backward or forward cache. But LCP should be measured in these cases since users experience them as a distinct page use. Okay. So where is the important? Where is backward forward cache? I think they may have. Okay, yeah, it's mentioned. Okay, fine. Measure user experience of web page across a variety of dimensions: loading, speed, interactivity, visual stability. Since users experience BF cache restores as faster navigations than traditional pages load times, it is important that core web vitals metrics reflect this. After all, the user doesn't care whether or not BF cache was enabled; they just care that the navigation was fast. So let's first understand backward forward cache, because otherwise this will not make sense. Over here, backward. If I just say BF cache, nah, not here. Okay, we'll have to Google it. Backward forward cache is browser optimization that enables instant backward or forward navigation. It significantly improves the browsing experience for users, those who have slower network devices. As a web developer, it's critical to understand how to optimize your uh, pages for BF cache across all browsers. So your users reaps the benefits. Supported in Safari and Firefox for many years across desktop. Cool. Starting in version 86, Chrome has enabled BF for cross-site navigations on Android for small percentage of users. In subsequent release, additional support slowly rolled out since version 96. BF cache is enabled for all Chrome users across desktop and mobile. Okay. And then in-memory cache that stores the complete snapshot of a page, including the JavaScript heap, as the user is navigating away. With the entire page in memory, the browser can quickly and easily restore if the user decides to return. For how many times have you visited a website and clicked the link to go to another page only to realize it's not what you wanted to click and click the back button? In that moment, BF cache can make a difference. However, in how fast the previous page loads, okay, make difference in how fast. Okay, fine. Without BF cache enabled, a new request is initiated to load the previous page, and depending on how well that page has been optimized for repeat visits, the browser may have to re-download or reparse. Okay, fine. With enabled, reloading the previous page is essential instant because the entire page has been restored from the memory without going to the network at all. Okay, so here they show it basically how it works, but I think we get the gist. Okay, so I'm just looking how do we add it to BF cache? Like, is there anything we have to do, or is it the by default? I don't think it will be by default. How cache works? The cache used by a different from HTTP cache is also useful, but yeah, BF is separate and their page including JavaScript, whereas HTTP cache contains only the responses for previously made requests. Since it's quite rare that all requests required to load a page can be fulfilled by HTTP cache, repeat visits using BF cache restores are always faster than even well optimized non-BF cache navigations. Creating a snapshot of page in memory, however, involves some complexity in terms of how best to preserve in progress code. For example, how do you handle set timeout calls where the timeout is reached while the page is still in BF cache? The answer is that browser pause running any pending timers or unresolved promise, essentially all pending tasks in JavaScript task queues, and resume the processing tasks when or if the page is restored from the BF cache. Okay, cool. If in some cases this is fairly low risk, for example, which in the other case it might lead to very confusing and unexpected behavior. For example, if the browser pauses a task that's required as part of IndexedDB transaction, it can affect other open tabs in the same origin, since the same IndexedDB can be accessed using multiple tabs. As a result, browsers will not attempt to cache pages in middle of IndexedDB transaction and or using any API that might affect other pages. Okay. Is optimizing the browser to automatically. Okay, this is done automatically by browser. It's still important for developers to know what is happening so you can optimize. Okay, so from what I read, it's happening by default. The browsers do it by default, but you can optimize it. But we'll learn about this later. Okay, this is the actual spec. Task queues, micro task queues. Hmm. interesting. Task queues are sets and not queues is something that I learned recently. Microtask is not a task queue. Okay, but this is a topic for later. So where were we? BF cache. We understood what is BF cache. Over here, here. Core web vitals. We are just not over here. Maybe over here. The API does not report large LCP entries when the page is restored from backward forward cache, but LCP should be measured in these cases since the users experience them as a distinct page visit. Okay. So this API does not measure the LCP again when the user visits the page back from BF cache, but according to Google, they are saying that the LCP should be measured because for them it's a distinct page visit. The API does not consider elements within iframes, but to properly measure LCP, you should consider them. Subframes can use API to report their LCP entries to parent frame for aggregation. Okay, cool. Rather than memorizing all the subtle differences, developers can use the library. Yeah, obviously, if you are taking care of all these things on your own, rather than that, just use the library. It's just this get LCP, and console log will put it to console log, and you can put any callback over here, which will put it to your uh, analytics. Great. You can refer to source code of get LCP to for okay, not for now. In some cases, see limitations of web vitals. Okay, there are some limitations also for web vitals. Example, cross origin iframes. It's not possible. Okay. What if the largest element isn't the most important? In some cases, the most important elements on the page is not the same as the largest element, and the developers may be more interested in measuring the render times of these elements instead. This is possible using the element timing API as described in the custom metrics. Okay, how to improve LCP. So actually, the optimization of LCP we'll see in a different section. That will be in detail. So LCP is primarily affected by 4 factors: slow server response times, okay, render blocking JavaScript and CSS, okay, resource load times, and client side rendering. Great. So slow server response, like if your server itself is taking longer to send over the entire HTML, okay, then obviously it will be an issue. Render blocking. So render blocking meaning, so there is entire critical rendering path, right? In that path, if there is any JavaScript coming in, okay, so whenever your HTML is there in the HTML, if you have not deferred your JavaScript, or the JavaScript is required to load your HTML, then those are render blocking, so that those will affect your LCP. Same goes for CSS. Those are also render blocking. Then resources load time, meaning any image, like if it is a large image, it will take long time to load. Same goes for, I think, web fonts. Then client side rendering. Yep, because in client side rendering we send all our JS to the browser, and then at the runtime the JavaScript creates the DOM. But if it's a server side rendered, then the DOM is created, like the HTML doc is created on the server, and it just sends the HTML doc. So yeah, those are the couple of things, not couple, 4 exact things which will help us improve LCP. For a deep dive on how to improve, you see optimize LCP. For additional guidance on individual performance techniques, you can also improve. You can see apply instant loading with PRPL, optimizing critical rendering path, optimizing CSS, images, op fonts, optimizing JavaScript. Okay. Oh, went into too much depth. Nice. Let's see if this contains this, then I won't do it, but But anyways, I'm done for today's session. I thought I'll cover LCP, FID, and even CELS, but turns out it has too much of content. Great. So anyways, it's fine. Like, we can learn slowly. So this is just optimize LCP, but these are also there, so we can learn about that. I think that's part of this fast one. So there's another series for fast load times. We can learn about that in that. Cool. Great. But what I'm missing is, like, there is no practically implementing anything. So let's do some sessions of this, learning sessions of this. If it gets a bit boring even for me, then we'll jump back and forward to some other things like learning responsive design. We can learn responsive design, and then in a couple of next sessions we come back to this performance. We can just go back and forth. And also, I think on this weekend, so Sunday, what I'm planning is to start teaching React. Okay, the first session will be of React. I finally decided it will be React. That will be a full teaching session, not a learning session. So please do join live learning session. And yeah, it's going to be awesome. This course I already taught to a lot of people, and they have appreciated it very well. They have rated it 9 out of 10 on an average, and everyone has benefited and switched jobs and got an awesome packages. So you can definitely get knowledge from that sessions. Yeah. So, and also I'm not sure if my face is getting cropped or not in these sessions. I think if not, if it doesn't add anything, then I'll just remove my face from these learning sessions at least. In teaching I'll keep it, but in learning I'll just remove it. But yeah, that's it. If you are watching this video later and if you find it beneficial, do let me know in the comment. Otherwise it's fine. I don't think anyone will be interested to watch a video where someone is learning, but it helps me focus a lot. Like, this is like amazing focus that I get. So yeah, I'll keep on doing it till I don't. Yep. So chalo, bye bye.